Okay, guys, we continue with velocity and speed. Okay, so since when an object is moving in a circle, so there are a few things we need to consider. Okay, first one is about their speed. Okay, speed means we are only looking at their magnitude, right? So it's a scalar quantity because scalar speed is a scalar. And if you look at velocity, velocity is magnitude and direction, so you have to consider both. Okay, for example, like okay, when an object is moved in a circle, let's say I draw this way. Okay, a big circle. Okay, this is the center of circle and the radius with r. And from previous lesson we know that okay, the speed is equals to 2 pi r over t. This is speed of object that moving in a circle. So we call this as a linear speed of a circular motion. A circular motion. Okay, what does it mean? A linear speed of a circular motion. So it means okay, the object is moving in a circle but it possesses a linear speed. Okay, that's the meaning of this. Okay, for example, like here, okay, let's say the object is, we have an object or trolley or car is making roundabout with radius of r. Okay, just imagine as a roundabout. Okay, so at this point, so what happened, the car is not following the circle or the dotted path. Okay, so what happened at this point, so actually the car is moving tangent to the circle. Okay, tangent to the circle with speed v. Okay, let's say v is 10 kilometer per hour. Okay, just say it's a 10 kilometer per hour. But when it's reached at this point, okay, what is the direction of the car now? Okay, so at this point the car is moving here, but when it's reached at this point, so what happened, the direction of the car is changes, so another tangent to the curve. So now the speed is here and the speed is maintained 10 kilometer per hour because it's moving at constant speed in a circle. Okay, same goes for at any point, okay, the car going to move at tangential speed which of 10 kilometer per hour. At this point it's moving downward kilometer per hour, and here also same thing, so it's moving tangent to the curve with v equals to 10 kilometer per hour. So if you look at each point, it's moving in a straight line, so that is we call as a linear speed. But the car is moving in a circle, so we call linear speed of a circular motion. Okay, so it means okay, it is moving at a linear speed or tangential speed at constant speed. So you can see 10 10 10 10 10. Okay, so it means the v is constant. Clear, right? Okay, so to find the speed, so we use 2 pi r over t. Okay, that's the formula we're going to use. So we need to know what is the r, the radius of the circle it's moving in, and also the time taken to make one circle is we write as a t. Okay, so that is the first thing. Okay, now my question is, okay, does the car accelerating? Does the car is accelerating? Okay, in this case, is the car is accelerating or not? We know that okay, the v is constant, the speed is constant. Okay, from linear speed, okay, what we know is okay, anything that moving with constant speed, Okay, so they don't accelerate. That's what we learn from linear speed. Okay, but under projectile motion, so if you look at under projectile motion, so when you throw an object upwards and then when it's reach your end again, so we consider as there is an acceleration of 9.81. Okay, so that is okay when it's moving under influence of gravity. And if you look at in another case, okay, where it's move and a car or an object is moving at a linear speed, after that when it's make a U-turn. Okay, when it's make a U-turn, so while it's U-turn, so actually the car is accelerating. Okay, why it is so? Okay, why it's even though it's moving at a constant speed, okay, so it is accelerating. That's my question now. Okay, now we look at, okay, we have a few condition to determine whether the object or the car is accelerating or not. Okay, so if you look at acceleration, okay, acceleration means, so we know that, okay, acceleration is A is equals to changes in velocity over time. Okay, so time is a scalar quantity, but v or changes in velocity, this is velocity, so this is vector quantity. Okay, so it's a vector quantity. Okay, now, so since it's a vector quantity, so you must look at two things. One is magnitude, another one is direction. Okay, so now, so acceleration is determined by changes of velocity over time. Time is scalar, so we don't look at time, we just look at the velocity. Okay, velocity is vector quantity, so it has a magnitude and also direction. Okay, so if any one of these changes, then we can say the object is accelerating. If both are constant, then we say the object is not accelerating, it's just moving with constant velocity. Okay, for example, like in the linear speed, okay, let's say we have a car here and this car is moving at 10 meter per second until it's reached 10 meter per second. So if you look at here, okay, magnitude and direction. Okay, magnitude and direction. Okay, so magnitude is 10, so it's a constant c. And if you look at the direction, initially it's moving to the right, and in this case also it's moving to the right, so there is no changes in direction, so direction is also constant. Okay, so in this case, since both constant, okay, both constant, so we can say that, okay, the v is constant. Okay, so v is constant, velocity is constant, so acceleration 0. Okay, so this is first case. Okay, in second case, okay, now, okay, so this is moving at 10 meter per second, then after that it's a U-turn, and then it's moving backward at 10 meter per second as well. Okay, so in this case, is there any changes in magnitude? Initially it's 10, and also after you change this direction also it's a 10, so it's a constant magnitude. But how about the direction? So direction, initial direction is to the right, and after that is to the left, so there is a changes. Okay, so when one of these changes, so the acceleration is not equals to 0. Okay, so that is what happened in this case, where you can see that, okay, the magnitude of the speed is no changes. Okay, magnitude is no changes, it's a constant. But if you look at the direction, okay, at each point, so here is in this direction, here is to the left, downward, to the right, to upward, so I mean the direction changes. So when direction changes, so the acceleration is not 0, so there should be a acceleration. Okay, that's the one we're going to find next. Okay, so these are the two cases, magnitude and direction changes. Okay, how about one more case? Okay, initially it's moving at 10 meter per second, and then it's reached a speed of 25 meter per second. Okay, for this case, we look at this. Okay, magnitude from 10 become 20, changes, and direction to the right, so it's a constant. So since the magnitude changes, so the acceleration is non-zero. Okay, so this is how do we identify whether the object is accelerating or not. Okay, not necessary if the magnitude is constant, okay, or it's moving at a constant speed. So it's not necessary, okay, its acceleration 0. So you also must look at its direction as well. Okay, you get it, guys? Okay, so now, okay, we already look at, okay, okay, the speed and also the velocity. Okay, and so next we're going to look at acceleration in the next slide. Oh, sorry, next video. Okay, before that we look at, I just recap the whole thing. Okay, you can see that when it's moving in a circle, it's moving linearly or tangent to the circle at each point. So I mean the direction changes, even though it's from this point to here. Let's say from here to here. So even a slight movement or small changes can cause the changes in the direction. Okay, so it means every point is counted as changing in direction. Okay, so when there is a changes in direction, so we can see that the object is actually moving at a velocity. Okay, so this is a velocity. Okay, so when there is a changes in velocity, then it will cause the object to accelerate. Okay, so that is what we learned from this video. Okay, so any questions? Okay, please don't hesitate to ask me, okay, in the during our live lesson later. Okay, thank you guys.